Very good. Now, let's go back and look the pavement design again from a bigger picture. So why do we really need to change the pavement design from MASH 93 or very simple to pavement ME? Many reasons. Hopefully by now you're kind of convinced why it is so important that we changed from MASH 93 to pavement ME. It's a lot more accurate, a lot more properties of the materials, traffic, they're all included. And also, if you think about new materials such as polymer modified materials, hydro mixtures, chrome rubber modified mixtures, a whole bunch of things, the performance of those can be truly seen in the when you do a pavement ME based design, and you can have a much better understanding of what is important and what is not important. And I'll show you in one of the examples, you may even identify if there's an engine oil in binders. Now, this is one of the things that you can do. For example, you can look at the effect of a polymer modified binder on rutting predictions. For example, what you are looking here is a design limit. One example with an unmodified binder, this is how the rutting would progress, and this is the design limit. And when you use a polymer modified binder, what kind of an improvement you see. When you use a high wrap binder, a high wrap mixture, hot mix asphalt with a high amount of recycled asphalt in it, what kind of an improvement or change you would see. And it's clearly, you can see how much change there is in when you use a new material. So that is one of the really neat ways of looking at different materials and how they perform in the field. And you can also look at the fatigue cracking prediction. So for this particular graph shows HMA with high wrap and unmodified binder, modified binder. So you have a little bit of less in this particular case, a little bit of less relative to the unmodified binder. But this particular study was not done by varying the material damage models. They only looked at the stiffness, so they only changed the dynamic modulus into this one, and then they looked at the difference. So you would see, because of the change in modulus, you would see a much more amount of cracking, even though all of them meet the requirement. But you can see that over time, over years, how the fatigue cracking develops by changing the materials. Now, also another thing, you can do cost-benefit analysis. So, which one would be more economical? A stiff material, a polymer modified material, but that is thin, or a soft material that is thick. So 70-22 is a polymer modified binder, 70 plus 27, that's 92 total. So that's probably a polymer modified binder. So it should be more expensive, clearly. That's a polymer modified binder versus 64-22, but this is a thicker pavement. So which one is more economical? So if you actually look at, so the design, let's say if your design is a fatigue cracking based. So if you look at these two designs, if you go back here, these two designs have identical fatigue cracking performance. So this is the design at the 20 years. This is the threshold in this particular case, even though default threshold is 25, but in this particular case, the threshold chosen was 12%, let's say, for this design. So you can do a cost-benefit analysis like this. For example, look at this. So unit cost of this, these are real numbers from a bid tab. For stiff and thin mixture, you have $140 per ton, 76-22, $100 per ton, 70-22 mix. And thicknesses are 3 inches and 4 inches. Lane width is 12. If you do the math, you can come up with the amount of weight for a given mile. And you can calculate the total cost, just material cost. This is only material cost. $328,000. If you look at the soft but thicker payment, even though unit cost is significantly less, $85 per ton for this mix, 6422, but it's thicker. So if you do the math, if you calculate the amount of ton and then amount of actual dollars, if you look at this, stiff but thin pavement is significantly cheaper, $220,000 cheaper. No, I don't know if it's significant, but cheaper, okay? It's $20,000 cheaper. So which one would you choose? I would choose this one. It's also a polymer modified binder. So,
would you have any additional maintenance with the thinner pavement?
Addition? No.
You know, yearly maintenance,
No.
which would factor into the cost benefit.
I mean, I can't think of a reason why there would be a different.
In the actual performance.
Yeah, this is the actual performance you're predicting with the years, with pavement ME, including the climate and changes in traffic. Everything is included here. This is the bottom line. So this is the bottom line. This includes all the factors that we have been talking about. And this is a true comparison of which mixture is better. Now you can also look at effect of super heavy vehicles on the pavement performance. This was one of the projects that we tried to get, but we didn't from Federal Highway Administration. But we have done a lot of analyses, effect of all these axles and how they cause damage in the pavement. And you can also look at effect of tire configuration. So you have a super single here, you have a dual tire here. So if you run this test in Mepdg, or if you run the simulation, Mepdg will say that super single tire causes 27% more damage than the dual tire. Well, NCAT tests at CanCat shows the opposite. So Mepdg is not always telling the truth. Okay, so you have to think about Mepdg is a great tool, but pavement is not being designed by the Mepdg. Pavement is designed by you as the engineers. Okay, so you only use the pavement ME as a tool if the results, and you have to always check the results if they make sense. If they don't make sense, if you have some data that is against that, then you have to be careful. So in this particular case, when you effect of super single versus dual tire, the assumption of circular load was not accurate, and layered viscoelastic model really needed, truly layered viscoelastic needed. So Mepdg really was a little bit short of the prediction. And that's what this says, black box syndrome needs to be overcome. So we are designing the pavement, not the software. So we don't want to use the black box as a black box. We need to understand.
NCAT says that, yeah, it's going to go straight.
Yeah.
But if you look at it, two tires, doesn't matter whether it's circular or whether it's some other shape. But two tires will give you more area to distribute this load than a single tire.
Not necessarily. How about the gap in between the tires?
Even if you take that, I think still, if there are two tires touching the pavement, their contact surface area should be more than the contact surface area of a single tire, whether that's combined or.
Yeah, I mean, and also you need to really look at the tire footprint, whether it is circular or more square. So depending on the tire footprint, Illinois did a lot of study on actual tire footprint and how that affects the actual damage and strains and everything. So those things needs to be considered as well. So apparently, NCAT, they actually measure the strain levels at the bottom of the pavement, super single versus dual tires. They actually looked at it, and super single was straining less. That's what they've seen. And field observations are usually pretty valuable. Okay, so pavement ME is very useful for for evaluation of new and recycled materials and pavements, conflict resolutions, It is an objective assessment tool. It could be used for forensic analyses. And for industry, industry can come up with the new and innovative materials and designs. So I'd like to show one of the reports that we've written for MDOT. There was a study that we've done. So we developed a method to assess new and recycled materials in pavements. So in this project, what we did was, if somebody proposes to MDOT, okay, I have this brand new material that I'd like to use in pavements. It's beautiful material. It will perform better than any other. So how would an MDOT make a decision on whether to try it or not? So we actually came up with a procedure for that. And in this procedure, we included a two-stage approach. The first stage is the evaluation of performance of the material. And this was for both all types of pavements like asphalt, concrete, and materials that are proposed to be used in base, upgrade, and all that. So and then the first portion was, let's focus on asphalt. Asphalt, the performance of the asphalt. Let's say a warm mix asphalt, a new warm mix asphalt, or crumb rubber, polymer, whatever it is. Let's say a new warm mix asphalt is proposed. There's a procedure that I'll describe in a minute that you go through, and after that procedure, you come up with a certain performance score, performance comparison between asphalt, traditional asphalt, and warm mix asphalt that is being proposed. And that performance is used in sustainability evaluation, life cycle cost in this stage 2, and based on engineering performance and sustainability performance, and there's an overall performance score is generated, and then the MDOT looks at that performance score. If it is positive, meaning that the new material is performing better than the traditional material, then they can accept to try it. If it's negative, they can reject.